Today, we will learn how to factorize using the first algebraic identity for an expression in the form of a square plus 2ab plus b square. Previously, we have learned that the first algebraic identity is a plus b whole square equals to a square plus 2ab plus b square. The process of simplifying from the left to the right is actually called expansion. Since we know that factorization is the reverse process of expansion, we can actually factorize a square plus 2ab plus b square using the same algebraic identity to give us a plus b whole square. Let us analyze the expression a square plus 2ab plus b square even further. We realize that the first term, a square, and the last term, b square, is actually perfect squares. So in order to use the first algebraic identity and to substitute the values of a and b, we need to square root these perfect squares. So let us take a look at an example on how to factorize for b square plus 12b plus 9. We notice that for this expression, there are three terms such that the first term and the last term are perfect squares. So before we can find the value of a and b to be substituted inside this first algebraic identity, we need to square root these perfect squares. So as a side working, to find the value of a, we actually square root first perfect square, which is 4b square. So square root of 4 will give us 2. Square root of b square will give us b. Next, to find the value of b, we need to square root 9. And this gives us 3. Next, we need to check that when we multiply 2 times the value of a times the value of b, it should give us the same as the middle term. So therefore, let's check. When we multiply 2 to the value of a, in this case is 2b, times the value of b, for this case is 3, is actually equal to 12b. And when we compare to the middle term, it is actually the same. So therefore, we know that we have factorized it correctly. So 4b squared plus 12b plus 9 is actually equal to the value of a plus b whole square, which is 2b plus 3 whole thing square. So this is how we factorize using the first algebraic identity.